Alright, welcome to section 6.2, multiplying and dividing radical expressions. The first problem is multiplying these two radicals together. We are allowed to multiply these two radicals together because they have the same index. So if this was a 3 and this was a 4, all bets would be off. But since they have the same index, we can go ahead and multiply these two numbers together. So we're going to make one big fourth root. And I'm going to multiply these two numbers together. 125 times 405 is 50,625. 50,625. Now, I've listed out all of the fancy numbers on the colored paper. This is just a white one here. But remember, if I want fourth root, I look in the fourth column. And I go down, boom, right there, 50,625. So what is 50,625 made up of? It's made up of 15s. So the answer to this question is 15. 15 to the fourth power is 50,625. All right, so there's the first one. We can multiply as long as the index is the same. This here is an intermediate one. We're not multiplying here. I'm going to show you how to simplify this. So if we have a cube root, we can simplify by taking out the largest perfect cube, kind of like we've been taking out the largest perfect square. So before, what we did was this. We have like the square root of 50. You'd split it up in the square root of 25 and the square root of 2. So you get 5 radical 2. That's what we did before with square roots. Now we're going to expand that to cube roots. So we're going to look in our list here, and we're going to say, hey, what number divides into 135? And we got to look in the cube list. So that doesn't, 64 wouldn't, does 27? So if you're not sure, you can take a calculator and you can divide it. So we're going to do 135 divided by 27. Does that go in there evenly? Yeah, 5 times. 5 times 27 is 135. All right, so we're going to split this into what we can take the cube root of, what we can't take the cube root of. And 27 goes in the front because I can take the cube root of 27, but I can't take the cube root of 5. Just like up here, I split it up into 25 and 2. Now, we have the E-I-E-I-O situation. E-I-E-I-O. That's the exponent, that's the index. We take this and we divide it in here. Does it divide? No. So we drop it down a power. Does 3 divide into 4? No. Drop it down a power. Does 3 divide into 3? Yes. So I make it x cubed and x to the second. I dropped it down twice. So let me move this 3 over here so I can, you don't see it, think it's wandering around here. So if I multiply this back together, 5 times 27 is 135. X squared times x to the third is x to the fifth, which is really what I just showed you up here. You can multiply two things together that have the same index to get one number. So we have cube root and cube root. This is the good cube root. So we're going to highlight this and highlight it. That's good. Everything there I can take the cube root of. I don't know if that looks so wonderful, but I highlighted it. Here, let me finish just highlighting it in. There we go. So I can take the cube root of this guy. This guy there, that's the junk. That's the junk left over. So the answer to this is cube root of 27, of course, is 3. 3 divided by 3 is 1. And the leftover piece is cube root of 5x squared. We're not going to worry about the absolute value on this section so much because we're going to say that all of the x's are positive, so we don't have to worry about absolute value. So there's the answer to this one. That's considered simplified. Uh-oh. All right, I said uh-oh because I needed to take a drink of water. I was about to cough, and I couldn't pause the thing for a second, so I said uh-oh, but nothing is wrong. I'm safe. Everything's cool. All right, so now we're going to multiply these two together, kind of like we did on example 1, and then we're going to simplify it like we did on example 2. Notice this is square root instead of fourth root or third root like the last two. So this is the square root. So 50 times 48 is happening first. We just multiply because those are the same index. So it's 48 times 50, which is 2400. So I get the square root 2400. X to the fifth and x squared multiplied together, and you multiply like bases, you add the exponents. And the same thing with the y. Now we're going to take this and break it up into what I can take the square root of, what I can't take the square root of. If I look on the square list, all the way at the bottom is 400. And I believe that works because 400 times 6 would be 2400. So I'm going to go square root. 400 goes in the front because 400 is a perfect square. It's on the list. 400 times 6. 6 is not a perfect square. There's an invisible 2 out here, the index of 2. So does the EIO thing takes place? Does 2 divide into 7? No. But drop of power, does 2 divide into 6? Yes. So we make it x to the 6th and x to the 1st, or just x. Does 2 divide into 6? Yes. So we take the whole thing to the front. So this is sorted out correctly. We have all the perfect squares in the front, and the junk is left over in the back. So 2 goes into 7, no, so I dropped it down to 6. I made it x to the 6th. Does 2 go into 6? Yes. Whole thing to the front. This times this. All right, now I'm going to take the square root. Square root of 400 is, now I know if I gave you 20 $20 bills, you could figure that was 400 bucks. So it's 20. There's an invisible 2 there. 2 divides into 3. X cubed. Again, y cubed. Square root 6x. All right. This is an even odd situation, but like I said, we're going to assume that all of the x's are positive. That's pretty much what it says in the book, so we don't have to worry about the absolute value here. So we multiplied, and then we simplified. This is, well, remember the name of this section. The name of this section is multiplying and dividing radical expressions. So now we're going to do some dividing. So far we just did multiplying. And as you know, dividing is always not as fun. Another sip of water. Here we go. We're just going to divide. We can divide, remember, because these indices, that's plural for index, these indices are the same. So we can go ahead and divide these. So let's see. 189, whoops. 189 divided by 7. Let's hopefully it goes in there evenly. Yep, 27 times. So I'm going to make the cube root, 1 radical symbol, 27. And then when I divide like bases, what do I do with the exponents? I subtract them. So it's x to the 5th. Regular numbers you divide, but exponents, there's a different rule, right? With the exponents, you subtract them. Now we're going to split it up into what I can take the cube root of, what I can't take the cube root of. So make 2 radical symbols with the index of 3. 27, hopefully you've recognized after doing enough of these that the cube root of 27 is correct. And then we do the EIO business. 5 divided by 3. Does that work? No. Drop the power. Does 3 divide into 4? No. Drop the power. Does 3 divide into 3? Yes. So I make this x cubed. How many times did I drop? 2 times. So the cube root of 27 is 3. 3 divided by 3 is 1. And then cube root of x squared. Boom. That's the answer. All right, the last example is not so fun, but we're going to give it the old fancy try here and see what we come up with. We're going to rationalize this in the end so that they don't have any square roots or cube roots on the bottom of the fraction on the denominator part. So here we go. I'm going to focus on 4 over 32. That's a fraction, and I can reduce 4 over 32. Because if I divide each of these by 2, that works, but even better, I could divide each of these by 4. So 4 divided by 4 is 1, 32 divided by 4 is 8. So what I'm telling you is this is 1/8. So here we go, cube root. We need 1/8. So I got x to the third on the top. I got 8 on the bottom. I got y, and I got z cubed on the bottom. Well, guess what? Everything here escapes. We need, not everything escapes out of the radical. These 3 things escape. This doesn't. So we're going to make this escape, kind of, outside the radical symbol. So here we go. Did I copy it down? Yes. So this cube root of x cubed is x. The cube root of 8, of course, is 2. The cube root of z is cubed is just z. But what I have left is I have a 1 on the top, because the cube root of this is 1. But on the bottom, I have this cube root of y left over. And that's not considered good form to have an extra cube root left on the bottom. So what I need is I need 2 more y's to make this y cubed. So I'm going to multiply by the cube root of y squared. Now I have 3 y's on the bottom. But as you know, what you do to the bottom of the fraction, the denominator, you got to multiply on the top. Cube root of y squared. So this would give me x cube root of y squared on the top of the fraction, numerator times numerator, and on the bottom of the fraction, denominator times denominator, I get 2z, and then this times this is the cube root of y cubed. The cube root of y cubed, of course, is y, so I'm left with x cube root of y squared over 2. This is y, alphabetical order, and then z. Now, this may not look simpler, but it is. This is considered the simplest form because there's no radical in the denominator. There's a radical in the numerator. That's okay. The key to this is right here. There's 1 y down here. I need 2 additional y's to make it a cube so I can cube root it. So I multiplied the bottom of the fraction, the denominator, by y squared, and the top of the fraction, the numerator, divided it by y squared as well, hidden inside the cube root symbols. All right, so the name of this lesson was multiplying and dividing radical expressions. We simplified one here, which was kind of like dividing. This was straight up just dividing and simplifying. This is the easiest of these variety. We multiplied and then simplified. In example 2, we simplified, showing you that 2 things multiplied together make this, but you can simplify the first one. And then, of course, we multiplied and simplified this, just looked it up on our chart.